All right, we're on to part C now. And part C, we're going to do more examples of drawing these like Lewis diagrams that show how molecular compounds are held together. So with that, let's go ahead and get started. All right, so we're going to do one more. The next one I want to do, let's do, I guess the stuff you're exhaling right now, carbon dioxide. What does it look like? All right, step number one, draw a sketch of the arrangement of the atoms with the atom with the smallest subscript goes in the middle. That'll be carbon. And then the two oxygens, we'll just spread them out. Eventually, we're going to connect them to that carbon, aren't we? All right, step two, count up your valence electrons. All right, so carbon dioxide, 1 carbon and 2 oxygens. Carbon, 4 valence electrons. Oxygen, 6 valence electrons. So if you add it all together, there's going to be 16. All right. So now we're going to use those 16 electrons. We're going to give everybody 8. All right. So I already told you, place you got to start. Outer guy's got to connect to the middle guy. So we'll do that. Now, right now, carbon, I suppose, would have 2, 4, right? So we got to get them up to 8. So give them, oh, let me erase that. Got to get them up to 8. Let's start with the carbon. Give them 4 more. I forgot to write 16. There's 16 electrons there. And then, let's see, oxygen right now has 2. So got to give them, what, 6 more to get to 8. And then the other oxygen's the same. He's got 2 he's sharing. Get 6 more. Got to grab 6 more. Get him up to 8. All right. There we go. That's 2 dots right there. A little messy. Hopefully you can read it. All right. So I think we got everybody at 8. Carbon's got 4 he's sharing. 4 belonging just to him. Oxygen, they're sharing 2 and they have 6 on their own. So yeah, everybody's got 8. So last thing we got to double check. It better add up to 16. Should add up to 16, right? It's got to add up to the total we added up. Let's see if it does. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's a problem. Nature is only giving us 16 to work with, but in that drawing when I added them up, I used 20. There's too many in this drawing. Oh, I should probably write this up here. There are too many in this drawing. Right now, this drawing, you can add them up again if you don't believe me. It adds up to 20. There's only supposed to be 16. So wait a minute. Is there any other way we could do this drawing? Is there any other way nature can use these electrons to get everybody 8 and only use 16, which is the amount we have to work with? Turns out there are other ways. So what we've drawn so far, where you've seen connections between 2 atoms and 1 line, that's called a single bond. But nature sometimes, instead of sharing 2 electrons, she can tell 2 atoms, you need to share 4 electrons. And when she shares 4 electrons, that's a double bond. So that's called a double bond. So let me show you another way of doing it. So one thing I want to mention so you don't get mixed up. I'm going to tell you, instead of trying one connection between these atoms, a single bond, you might need to try double bonds. Single bonds usually work. Single bonds are the most common kind of bonding that exists in the universe, this sharing of 2 electrons. If it doesn't work out, that's when you want to try a different kind of connection, a different kind of bond, a double bond, okay? So don't just start with the double bonds. Try single bonds. If it works, great. How do you know if it works? Did you give everybody 8? Did you use the right total? If it doesn't work, now it's time to try another option. Another option is a double bond. Let's try it down here. So same idea, but instead of just having 2 electrons getting shared, let's say, well, maybe they share 4 instead. 4 and 4. Now, if we do it this way, carbon already has 8. 4 on its left side, 4 on its right side. He's already got 8. Carbon has 8. So he doesn't need any more. Carbon already has 8. Now the oxygen has 4. So oxygen still needs more. Oxygen needs 4 more to get to 8. 4 now he's sharing. 4 just for him. That's 8. The other oxygen, yeah, he's sharing 4 as well. So he needs 4 more to get to 8. So this is another way to give everybody 8 electrons. Now, the problem before was it didn't add up to 16. Well, let's see if it adds up to 16 this time. So this other option, let's see. 2, 4, 6, 8, 10, 12, 14. Oh, 16. That's what it's supposed to add up to. So it adds up to the right total, and everybody has 8 electrons. I'm going to erase these marks. So this is really the drawing, the right way that nature puts together carbon dioxide. She uses double bonds between the carbon and the oxygen. Now, if you're wondering, are there any other options you haven't told me about yet? Well, there's one, and that is you can actually have a triple bond. Oh, this got a little cut off here. But you can also have a triple bond. So you can have a single bond, you can have a double bond, or you can have a triple bond. All right, so there's no such thing as a quadruple bond. The highest it goes is 4. All right, so again, you're going to have to try out different options until you get the right one. How do you know if it's the right one? Did you give everybody 8 electrons? Did you use the right total? Try single bonds between atoms. If that doesn't work, you can switch, try double bonds. If that doesn't work, you might need to try a triple bond. All right, so with that, let's do one more example. Let's do one more example. All right, so let's flip over and we'll try one more along these lines where there's maybe we got to figure out what kind of bond we're going to have. All right, let's do another one. All right, so next one I want to do is let's do HCN. So hydrogen, carbon, and nitrogen. They're all together, and we want to figure out how they're connected. How are they all joined together? All right. So, okay, this one's going to be a little tougher, a little trickier than what you've been seeing so far. So let's see if we can do it. All right, so it says, draw a sketch of the arrangement of the atoms. The atom with the smallest grip will be in the middle. All right. Wait a minute. This time, there's a tie. There is one carbon, one hydrogen, one carbon, and one nitrogen. So typically, you know, like in carbon dioxide, I said, oh, carbon's going to be your middle atom. You just have one of them. But now in this molecule, there's a tie. One hydrogen, one carbon, one nitrogen. Which one do I go with? Well, there's a tiebreaker. The tiebreaker is if a tie, use, oop, wrong letter there, use the atom further left on the periodic table. I'm just going to write PT because I'm running out of room. One more thing I should tell you. Oh man, I should have left myself more room here. Never hydrogen. Hydrogen can never be a middle atom. So in this example, for R3, hydrogen will never be in the middle. So it's either going to be carbon or nitrogen. Which one? Carbon, because it's further left. So my sketch is going to look something like this. All right, now in a minute, we're going to put in those electrons. We're going to figure out how to give everybody 8. So if you have a tie for the lowest subscript, go with the element further left on the periodic table, never hydrogen. All right, next one. Still got to add up our valence electrons. So let's go ahead and do that. Oh, shoot. I meant to erase that. There we go. All right, so one hydrogen, one carbon, one nitrogen. Hydrogen brings 1 to the party. Carbon is going to bring 4 to the party. Nitrogen is going to bring 5 to the party. I'm looking at the column numbers. All right. Now, for this one, now if you add it all together, the total adds up to 10. There's 10 electrons. So we're going to use those 10 electrons to give everybody 8. All right. So it's getting a little tougher because there's more than one option, right? You can have single bonds, or you can have double bonds, or I even told you it's possible to have a triple bond. So we're going to try out all these options until we get the right one. Everybody has 8. You only have 10 to work with. Now, let me remind you, everybody needs 8. Oh, there was one other little rule there, right? Except hydrogen only needs 2. All right, so let's try single bonds. All right, that's the start. Everybody needs 8 except hydrogen only needs 2. Carbon right now has 4 electrons on it. Give them 4 more. Carbon's got his 8 now. Nitrogen. Nitrogen has the 2 he's sharing. So he needs 6 more to get to 8. All right, now he's got 8. Hydrogen has his 2. So everybody's got the right number of electrons around them. So this is going to be the right answer if it adds up to 10. Let's see. All right. 2, 4, 6, 8, 10, 12. Uh-oh. Is that right? Oh, actually, I even missed. It's actually 14, I think. 2, 4, 6, 8, 10, 12, 14. Whoa. There's only supposed to be 10. So this is not the right answer. We're going to have to try something else. All right, so let's think about our other options. We know we could go with double bonds or triple bonds. All right, let me give you one other little bit of advice, and it's actually some I mentioned earlier. Hydrogens only need 2 electrons. The only thing they ever are going to do is a single bond. So that has to be a single bond. So what we're going to need to try is either making this a double bond and seeing if that works out, or making this a triple bond and seeing if it works out. Now, in the interest of saving us a little time, let me tell you the option that actually works, and you could think about it just to double check. It will work with a triple bond, actually. So if you look right now, hydrogen would have its 2, carbon would have 8. 2, 4, 6, 8. So neither one of those atoms need any more. So to finish this drawing up, nitrogen right now only has 6. 2, 4, 6. So he actually still needs a lone pair. And I think that's going to work. Everybody has 8. Does that make sense? I hope so. Does everybody look like they have 8? And I think we used the right total. The periodic table tells me it should be 10. Let's double check. 2, 4, 6, 8, 10. Adds up to 10. All right, so yeah, that's got to be the right answer. So it's going to have a triple bond here and then a single bond on the other side. All right, so with that, let's do a couple more. And again, I want to show you 2 more that are, again, slightly different. If you're getting a little mixed up on this, you know, in Zoom, we'll practice this a bit more. It'll help you out, I hope. But I at least want to show you all the different options, right? So there's more kinds of bonds. There's single and double and triple. We got to worry about all those kinds of bonds. And there's one other thing I want to show you. All right, one other thing you got to be familiar with. All right, let me flip over. All right, let's talk about one more topic in this video. So, and that is that you can actually do Lewis structure for ions too. All right, so again, slight variation you got to be familiar with, right? So what's an ion? An ion is just a charged particle. All right, so something like this, CCl3 minus 1, or NO plus 1. All right, so both of these are ions. So the good news for you is most of the work is the same. There's just a couple little changes. The things we did before didn't have a charge. Now they've got a charge. So most of the stuff you're going to do is the same. Step 1, draw a sketch of the arrangement of the atoms. The atom with the smallest steps will be in the middle. So for the example on the left, what's going to be the middle atom? Carbon or the chlorine? Carbon. All right. Now, let's talk about NO. Just so you know, in NO, there's only 2 atoms. So there's really no middle atom. You know, they're just going to be connected to each other. So that's going to be your sketch. Okay. Step number 2, add up the valence electrons. So again, we're going to do these side by side. So in CCl4, or CCl3, I should say, minus 1, you got yourself a carbon. You got yourself 3 chlorines. And then you have, let's see, carbon brings 4. Chlorine brings 7. All right, so if you put it all together, the grand total, the 4 from the carbon, the 3 from the chlorine, it adds up to 25. All right. Now there's one problem, which is when I add up this total, I haven't taken into account that this thing actually has a -1 charge. So there's not going to be 25 actually. If you have a -1 charge, you have an extra electron. The way you become negative is you've grabbed an extra electron. So this drawing is going to actually have 26 electrons in it. So I know it seems backwards. You have a negative charge, you actually have more electrons than normal. This fella is going to have 26 electrons in it. All right, let's do the other guy. How about NO plus 1? We're going to do the same thing. We got to add up our electrons. So this one, it's a little smaller. We got 1 nitrogen and 1 oxygen. Nitrogen brings 5. Oxygen brings 6. If you add them all together and there's just one of each, it adds up to 11. But wait a minute. It's not just NO, it's NO plus 1. So this seems backwards, I know. If you have a positive charge, you actually have fewer electrons than normal. So this fella isn't going to have, he's not going to have 11. He's actually going to only have 10. So you got to take 1 away because of the charge. He only has 10. All right, so that's one difference. The major difference is when you add up the electrons, you might need to adjust the total for the charge. If you have a negative charge, there's more than normal. If there's a positive charge, there's fewer than normal. All right, that's one difference. Now, the other difference is, the other stuff is pretty much the same. We're going to use those electrons. We're going to give everybody 8. In the interest of just saving us a little time, let me go over that, and I'll just tell you the way it should work out. For CCl3 - 1, if you use single bonds, it should work. Give everybody 8. Give everybody 8. Give everybody 8. Chlorine right now, the carbon right now only has 6. Those bonds, 2 more gets them to 8. So I could add them up. I think everybody has 8. You can look at that just to verify, right? Either by sharing or by lone pairs, and it's got to add up to 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That's the right answer. It's supposed to add up to 26. All right. So we've given everybody 8. I'll erase all these little marks. And we used the right total. Okay. Now, there's only one other difference. And that is when you do an ion, the drawing, you have to put the whole thing in the bracket. So you put a bracket around your drawing and you put the charge in the corner. That lets me know it's actually an ion. So it should look like that. So subtle differences when it's an ion, right? You use a charge in the corner and then you adjust the number of electrons. For NO, same idea. I only have 10 to work with. The way it's going to work out, let me again, because I don't want this video to go on too long, I'll just tell you. It won't work out with single bonds or double. It'll work out with a triple. If you have a triple bond there, and then that gives each atom 6, and then each atom has a lone pair. Yeah, that gives everybody 8, doesn't it? 6 they're sharing, and then 2 just for me. So everybody has 8, and if you add up the total, it adds up to 10. 2, 4, 6, 8, 10. So that's the right total, and everybody has 8. All right. Now, as far as this goes, we got to put it in a bracket, and you put the charge in the corner. All right. So with that, that's kind of all the options you need to be aware of. So let's do a little practice right now, and then we'll see if this is sort of making sense at least a little bit, I hope. All right, let's flip over to some practice questions. Practice question number 1. How many valence electrons are in the cyanide ion? Cn, and just to be clear, it's Cn minus 1. All right, so carbon is right here. Nitrogen is right here. How many valence electrons are in that? Don't forget, it's got a -1 charge. Okay, next practice question. We're going to do a couple more here, huh? Which one of these is the Lewis structure for CCS2? All right, I should tell you, I'm not going to be able to like draw these in the box, the little pop-up box you're about to get. So you might need to pause this, or you can look on the handout if you've been downloading those and see what these drawings look like. So one of these is the right drawing. So you're going to need to figure out how many electrons you got to work with, and then you're going to have to find which one of these uses the right total, and you've given everybody 8. Everybody needs 8, and hopefully you know the right total. All right, one last one. Let's see how we're doing. All right, which one of these is the right drawing? First, sulfur dichloride. Sulfur dichloride, this is the formula, SCl2. That'll be a little hint, all right? So you need to figure out how many electrons you got to work with. Look at your periodic table, figure out which one uses the right total, and you've given everybody 8. All right, one of these should work. Okay. All right, with that, if you're struggling with this, you're a little mixed up, hey, Zoom, we're going to practice this some more, or of course you can contact me and I can answer some questions from you. All right, so that's it for this lecture. We'll practice this, get a little better at it in our Zoom time, and then hopefully it'll be okay. All right, I'll talk to you next time. Bye-bye for today.